Welcome to Learn Geography with GIS. During this module we will talk about different geographic boundary levels and units, as well as about structuring your data so that it is mappable. Earlier, we introduced you to different types of spatial data. These ranged from street addresses to GPS location information to imagery captured by remote satellites and other sensors. Spatial data is the result of observations and measurements of the Earth's phenomena referenced to their location on the Earth's surface. In other words, it is about capturing what you see outside of your window and giving it some geography so that you can correctly place it on a map. We also introduced you to different layers and feature types needed to capture what you see outside of your window, all of which can be then integrated and captured on a map. Now that you have some ideas about the different ways that spatial data can be represented through different feature types, we will move on to talk about different geographic units and levels at which spatial data can be captured at. Every day we make reference to different levels of geographic data without realizing it. To give you some examples, have a look at this map. The lighter colored areas likely represent built-up areas, perhaps delineating the boundary of a town or city. If we now zoom out, other geographies will become visible, such as administrative boundaries. If we zoom out further, we can see the country-level administrative boundary, which captures the outline of Luxembourg, in this example. To further highlight geographic levels and units, let's start with a point location that is defined by a set of X and Y coordinates, as illustrated here, and may represent a street address or the location of a building. Next, this address may be associated with a parcel of land or property boundary, which can be represented by a polygon. This is located in a neighborhood and has a certain postcode. Again, these can each be represented by a polygon, and is situated within the boundaries of a town or city. The boundary extents of the town or city are captured by the polygon in light gray. This is situated in a county or municipality, as shown by the darker gray area, and is within a particular district or province, and so on. I think you get the picture on how these different boundaries can change to represent areas and geographic units. There are many different spatial units that can be used to represent information for an area. We have listed a number of different boundaries and conceptualizations of space that you may have encountered. This is by no means a definitive list, as different users may create their own boundaries and units. As you can see, there are many different geographic levels available that come in different shapes and sizes, and depending on the data they represent, also different units. So, boundaries come in different shapes and sizes, as defined by a set of criteria. A variety of standard boundaries are available. Some of these you will be familiar with and include political boundaries delineating different administrative boundaries. The geographic unit used for the data will depend on the data itself. This can be total number of a population, proportions, incidence rates, and so on. Now that we have introduced you to different geographic levels, let us now look at some real-world examples. Here we have an image with the different administrative boundaries for Luxembourg. These data are available in different GIS data formats. Remember earlier we introduced you to the different formats. Here you can see this data is offered in 4 different formats: KMZ, shapefile, GeoJSON, and a geopackage. Next, we will show you how these boundaries have been used to capture how the population is distributed in Luxembourg. In this example, the users show the population at the canton level. Every country has a set of defined administrative boundaries. Here is an example from Kenya. When we map each of these administrative boundary levels individually, you can see how these vary in shape and size across the country. Each country uses their own naming conventions to capture the administrative boundary level. For an overview, view the summary provided on Wikipedia, and illustrated here. We realize this is quite a lot to take in. Before we wrap up this module, let us have a quick look at the geographic units to use. There are a number of different geographic levels one can use to represent data that can range from X and Y coordinates to different sized areas. These can be defined by you, or you can use standard, political administrative boundaries such as county, municipality, district, state or province or country level, as shown earlier with the Luxembourg and Kenyan example. Keep in mind that if you do want to create a map of data that you collect, to ensure that you structure your information in a way that will allow for that. During the courses we offer, on occasion it will be necessary for you to combine data from different sources through a common geographic feature. On that note, let us wrap up this module. In summary, during this lecture we talked about different geographic levels and units and making data mappable. As you can see, geography is complicated. We hope that the examples we have provided will help you think about the different geographic levels that are available and how they can be used to capture information. Keep in mind when you are collecting information what the purpose of the data will be, what type of analyses you may want to conduct, and whether you want to make the data shareable, as this may dictate at what level you provide data to others. We hope this provides you with a brief overview of the different geographic units and levels at which one can capture information. That is all for now. For more information, visit our website.